Hey guys, welcome back, and today we're going to be talking about transferring Sol from one account to another. We talked about this before. Obviously, Sol are also called lamports. Lamports are going to be the smaller denomination of Sol. And the act of transferring Solana from one account to another is actually part of the system programs. Now, a system program is a program that comes with Solana by default. So it was created by the developers, it's part of the network, and that's exactly why you can send Solana to a friend or use Solana Pay. You don't have to go write a program on chain to be able to send somebody Solana. So it's part of the underlying ecosystem. But what we're going to see today is how you might use that system program in your Rust on-chain stuff. So before we get started, as you can see, we got the repo laid out here on the side. And we got this CI/CD script, which you guys have seen before. Just going to kind of help us do things a little bit faster. And that's all getting driven through NPM. Now, our package JSON is actually trimmed down a little bit. So we've got a little bit less dependencies here. And as you can see, like we said before, this is how we're triggering that CI/CD script. And now, if you also look over here, this is where our program is going to land. In this accounts folder, we've got these JSON files here, and each of those is an array of bytes that represents a key pair. So you'll see this file when you guys use that Solana keygen command that you saw in the first video and you create yourself a local key pair. This is the same exact process, except we're using it to create some accounts that we're going to do different things with in our example. And so this right here is the command. And I'm just going to open this up in the raw form here. And let's grab this command and see what that looks like. And so I'm just going to quickly change the name. Let's just do a test.json. And I put this transfer sol directory in here so you guys knew what it was doing, but I'm going to make sure that this lines up with where we're going to point it. And as you can see, that just generated a new key pair. And we saw this before when we first set up the CLI. There's the public key, there's our recovery phrase. And since we pointed it to that location, here it is right here. So that's how I made these accounts here. I made each of these key pairs. And now one more thing that we just want to do is we want to actually activate this account here. And the easiest way to do that is to just do an airdrop. So here's that same keygen command that we just did. So I'm just going to pull this all out and I'm going to say Solana airdrop -- key pair. Point it to that new test JSON, and then let's just do 1. And so once that finishes, we'll obviously get 1 sol, and that will also activate our account on Solana DevNet. Cool, so now that that's done, you guys see how that went. I'm actually just going to blow this thing away because we don't need it. But that's the process I used for each of these. That's in the README if you need it. And I also have their public keys here because they're not going to change since we're using these JSON files. So cool. Now let's take a look at some of their balances real quick. I got these key pairs here. Let's take a look. Let's start with Ringo. And I'm just going to do this really quickly because I want to know ahead of time what we're looking at here. Okay, cool. And as you can see, Paul probably has the most money here. So I don't know, that's maybe kind of accurate. But John in second place, and then Ringo and George. So this is important because we're basically going to be using John and Paul to send Sol around. So I wanted to make sure that they had enough to go around. I've already been kind of messing with this, so they are good to go. And now we're going to get into the code here. So we'll close these readmes out, close some of these folders down. And I guess we could start with the client since it's going to make a little bit more sense if we move in this order. Now I did manage to get our TypeScript code watered down a little bit more this time. Since we don't need to go create new accounts, do any of that create with seed stuff that we saw before. This is actually a little bit cleaner this time around. So I'm going to go through this and then I'll slow down as I barf out some code and we'll talk about what's going on here. So as you guys can see, we obviously just set up our imports here. And we're going to use all of these, even though they're kind of grayed out right now. And then we just got these variables here that I've declared up top so we can see what the most important like pieces are going to be to what we're doing. So we've seen connection before, and then we've seen program ID and program key pair before. That's obviously going to be once our Rust program is deployed. And then we just got each of those key pairs from the accounts folder for each of the beetles so that we can see their key pairs loaded into the program and we can use them to do stuff. So this function here is going to help us return a key pair from a file. And as you can see, this is a little bit more condensed than we used before. So we're going to use buffer here to actually get this done and the JSON parsing capabilities in TypeScript. And that'll give us the key pair from each of these files that we saw here. It actually will also give us the key pair from any key pair file that's represented by bytes. So the same thing for our program ID. And we're not going to use the local key pair, but if we did, it would be the same thing there too. And as you guys can see here, this is going to be our send lamports function. I just zoomed out a little bit because it was kind of getting a little crammed in here. But let's take a look at what's happening here. So right here, we've seen this buffer alloc function, which is allocate. And here we're just giving it 8 bytes so it can represent a number that's going to be in lamports. But this is just another way to serialize that data. So this is kind of a little bit shorter way to do it. Works out pretty good. And we're actually taking use of this buffer layout again. We saw it in the last video, but we're just using this LO module here in this case. So now we make this transaction instructions. As you saw before, we were using just one key. Like we had this bracket here, and we just provided one object. And so in Rust, when we were taking a look at the account info, there was just one account in there. But here we're providing 3. And the reason is, first, we obviously are providing the from. Okay, so this first account, we're using from. You're using that public key. And pay attention to this. This is the signer here. So in Solana and pretty much every chain out there, if you want to send any kind of coin, the sender has to sign the transaction, right? Like it kind of makes sense if you think about it. Like if I could sign a transaction where you're sending me money, then like I could just take whatever I want from you. So you need to basically permit this to go to the person that you're sending it to. So the first account is the signer, and it's not writable. The second account is the receiver, the 2, and they are not the signer, but they are writable, which is because we're going to be writing new values to that account. And thirdly, we provide the system program.program ID, and this is just going to be all ones. And that's because, like I said before, the actual transfer of Sol or lamports is a system program. So we need all 3 of these. And as you can see, the system program is neither a signer or writable. And we pass those in as the keys. We're using our program ID from up here. And then we're using that serialized data. And then our typical await, send, and confirm transaction that we've seen before. And that's all it takes to conduct the send lamports. So finally, what we're going to do below this is we're going to add our main section here. And in here, we're really just going to be conducting like a simulation. So we're going to initialize everything, and then we're going to simulate like a couple members of the beetles sending each other Solana. So I'll go ahead and write that out now. So as you guys can see here, we're just initializing everything. So we've seen the connection before. And then as I said, we're going to use this create key pair from file a few times. So we're doing it here to get the program key pair. And then down here, we're using it to get each of our beetles key pairs as well. So I added this section right here. If you guys need it, you can just uncomment this and it'll airdrop into Paul and John. Obviously, we already saw that they have plenty of lamports to do this, so we're not going to worry about that, but it is there. So I'm going to comment this out for now. And now finally down here is where we're actually going to write our simulation. So I'm going to just say John sends some Sol to Ringo. And I'm going to copy this console log stuff in there. We're just going to have some output here to tell us what's going on. So as you can see, John sends Sol to Ringo. We're going to print out John's key and Ringo's key just for our reference. And then here's our function call. So obviously send lamports like we saw before, right? So we need from as the key pair. We need just the public key of the receiver and then the amount of lamports that we want to send. So what we're going to do is, you probably figured out, we're going to pass John key pair. We're going to pass Ringo key pair dot public key. And I don't know, let's do like half a Sol, right? So that's enough to send lamports from John to Ringo. And now I'm just going to copy this, the other stuff in here. It's the same exact thing. But we're going to send some from Paul to George. And then we're going to send some back from George over to John. And that just looks like this. Okay? So in this case, we're doing 0.4 Sol, and here we're doing 0.2. So we're going to take a look at how these things change going forward. And of course, don't forget to add your little main trigger down here. And we're good in the TypeScript section here. So now let's flip over to the Rust. So in our librs, we're obviously totally empty right now. We got nothing in here. And so we're going to write just a little bit of Rust code to show you guys how to do this transfer. And it really isn't going to be much, but you know, you can easily see from this example how you can build on this and you can make it part of your on-chain programs. So we'll start with our use statements here. These are all the things that we're going to need. And of course, we have the classic entry point, right? And then down here, we're just going to do pub fn, and I will copy this boilerplate stuff in because you guys don't need to watch that. And of course, now that that's done, right inside this process instruction is where we're going to write this. So you've seen this before, right? The first thing we want to do is get that iter going. This is from Solana's docs. This is how they want you to do it. And then we're going to say let payer equal next account info. And it's going to be that accounts iter, if I could spell it. And we'll add a question mark there since it's a result. And let me copy this again and make this payee. So payer obviously being the sender and payee being the receiver. And this is how we initialize both of those. So now these are going to be this account info object here. And so each of these represents the account that are, that's going to be involved in this transaction. And now this is how we can get the amount without using any structs or anything. This is a way to convert that serialized byte array into an integer. We just do something like this. So we got that 8 there since we used 8 bytes over in our TypeScript here. We used 8 bytes here. Here we're obviously expecting 8 bytes. And here we're just using a little lambda to turn this slice into an int. Mapping it specifically into a U64. And then of course we're using OKOR, which is a nice little function that is going to return this error if that doesn't work. So this is really just a different way to write some kind of error handling in Rust. Kind of a neat little shorthand. And this will obviously convert into that amount of lamports. Nice. And then we add the question mark again there, shorthand for the result. And now that that's all set, the last thing we have to do is actually perform the transfer. So I'm going to add this little debug message here so we know what's going on. And we're just going to use that message macro that is provided by Solana. As you can see, receive request to transfer blah from blah. So this is going to give us some information about what's going on. And now here is all it takes to do that actual transfer. we're going to use invoke, which comes from Solana program. And we're going to use the reference here to system instruction, transfer, payer.key, payee.key, amount. And then we need to add this reference here to the accounts. It looks like this. Add the question mark again, since we're going to keep doing things shorthand here. And now we're done. So we'll just add this message here that says transfer completed successfully. And an OK. And that is all there is to it, ladies and gentlemen. That is all it takes. So right here is all we need in Rust to actually perform this. So you're going to grab the account information up here. We're going to deserialize that amount out of the bytes, some output, and then here's all it takes to actually do that transfer. So pretty neat. It's really not much code. And as you can see, this comes from Solana itself. And this is like what we were talking about here. This is a system instruction. So here you see system instruction, and also here you see it as well, system program. And like I said, this is built into Solana. So all we're really doing is building inside our Rust on-chain program the capability to use already existing Solana programs. So now that this is all done, we've already written this CI/CD script. So all I'm going to do is close this out, and I'm actually going to run this one here, reset and build. And just so you know, like if you guys wanted to check this out, it's on my GitHub, but this is what it looks like. And if we do reset and build, it's going to clear node modules. It's going to take down any running Solana programs. It's going to remove our program file, and then it's going to build all of our programs, deploy them, and then it's going to finally do an npm install and show us what programs are out there running, so that the next step is we can run our example. So let's do that. All right, so as you can see, this finally wrapped up here. And there's our program right there that got deployed out to the DevNet. And now before I run this thing, I'm actually going to move this up into the corner here. And we're going to open a couple of more terminals so we can see some of the action happening. And we'll keep things nice and clean. I'll go ahead and clear this output. Now, I guess I probably should have closed that this early because I want to actually take a look at that. I need that program ID real quick. But what we're going to want to do, we'll do Solana logs, grep, and I'm going to grab this program ID, and you guys have seen this a few times already, invoke, and the way we have this written, we only need 7 lines after that invoke, so that's what we're going to use. All right, so now let's rip it. Now, before we rip this thing, let's check some of the lamport values that we have in these accounts here. So let's go into our main, and let's take a look at, and my OneDrive is just causing all kinds of havoc here, by the way. Let's go ahead and take a look at what these accounts are holding right now before we run this. So John is going to send some money to Ringo. So let's take a look at what John's packing in his account here. So we'll start with John. We'll put him on the left down here. So John's going to have 4 Sol. And now we're going to take a look at Ringo. And as you can see, Ringo's got almost 1.4 Sol. So let's kick this thing off and we'll see what happens as we watch the logs. And as we also pay attention to what's going on with their balances. And as you can see, there's our program running just the way we predicted here. So we get this little bit of warning here about big int, and that's just because of some mismatch here with our dependencies. I honestly haven't narrowed this one down yet, but if you guys find out exactly what's causing this, let me know in the comments. That'd be great. But anyway, down here we can see our output. John sending some Sol to Ringo. And so that worked. And up here in our output from the program, we didn't put their names in there because we didn't feel like sending it over. But as you can see, like this is the system program here being invoked, all ones, like we mentioned. And there's our output message here, right? Transferring from 2AX, which is going to be John's, over to this 3C5, which is going to be Ringo's. So if we look at their balances again, we'll see that they have actually changed in value. And now obviously my conversions were way off. I think I did this a little bit too quickly. But this is not half of one soul. This is actually a lot less. That conversion looks like this. So as you can see, this is the value of one lamport versus soul. And so if we do some quick math here, this is what we can expect. So we should be in that third decimal point there. So taking a look at our results, we can see if we look over at Ringo, he started with this 0.374 and now he's got 0.379. So that's correct. We sent him 5. And I'm not even going to try to accurately represent this denomination. And now John, he differs by 3. And that's because he sent out 5, but then he got 2. So interesting, but that looks correct to me. And as you can see, we got our logs. Everything looks successful. And so that's it. We're good. We did it. We successfully transferred Sol from one beetle to another. And if they were alive today, I'm sure they would love to do this. And I'm sure they'd be big Solana fans. But until next time, guys, peace out.